A rocket of mass m is moving at constant speed in free space and initially has kinetic energy E. An explosive charge of negligible mass divides it into three parts of equal mass m over 3 in such a way that one part moves in the same direction as the parent rocket with kinetic energy E over 3 and the other two portions move up at an angle 60 degrees to this direction. Determine the total energy W imparted to the parts of the rocket in the explosion. Here we are told about a body moving with energy E. Along the line, it's split into three. So we have it like this. It moved like this and split into three. But what happened was like something caused the breaking up. I want to know the energy that was infused into it before it split into the three. Now, we have this one to be m. And we have this one to be m over 3. M over 3. M over 3. From the question, we also told that this place is 60 degrees. And this place is 60 degrees. Now, something else happened. We were told that the energy of this one that move along in the same direction, the energy here is E over 3. And the energy here is E. That is the kinetic energy. So we want to know what that power, the work done to cause this splitting, that is the energy infused into the system. Now, let us see what the velocity of this one will be relative to this. We know that the velocity here is 1. Let's call it 1. Let's call this velocity here v1, v3, v2. Let's put it that way. Now, we can also do something. Let's first of all find, this one is very easy to find since we have known the energy here. So, we can see that half m v squared is equal to E. Half m over 3 v1 squared is equal to E over 3. So, let's make this one 1. Let's multiply this one through by 3. So, we are going to have, okay, let's make it 1. Let's multiply this one through by 3. We are going to have half m, that is the m of that one, v1 squared is equal to E. So let's divide 2 by 1. So we are going to have half m v1 squared over half m v squared. So this is 1. So let's cut. So it means that v1 squared is equal to v squared. So v1 is equal to v. So that one is clear now. So we can see that our v1 is equal to v. There's a reason for getting all this like this, please. Now we have got to the relationship between the v1 and v and this v. We want to get the other velocities, and we can do that through conservation of momentum. So by principle of conservation of momentum, by principle of conservation of momentum, we realize that nv is equal to m over 3 v1 plus m over 3 v2 cos 60 along this line plus m over 3 v3 cos 60 degrees. Now, before we go on, let's multiply 2 by 3. So I have 3 mv is equal to mv1, this one plus mv2 cos 60 degrees plus mv3 cos 60 degrees. And we know that along the perpendicular direction, momentum is 0 because there is no component of this velocity along this perpendicular direction. Therefore, 0 is equal to m over 3 v2 sine 60 degrees reacted in opposite direction minus m over 3, so sorry, this one is v2, v3 sine 60 degrees. So, therefore, n over 3 v2 sine 60 degrees is equal to m over 3 V3 sine 60 degrees. So we are going to work with this. Now from this relationship, we can see that V2 is equal to V3. You can see V2 is equal to V3. Now let us bring this into this place. We have established that V1 is equal to V and V2 is equal to V3. So we can easily say that 3 mv is equal to mv plus n v2 cos 60 degrees plus n v2 cos 60 degrees. So let me make it like this. So I can say 2 mv is equal to 2 n v2 cos 60 degrees. Let's do another cosine. This one we cancel this. So I can easily say, and this one can now, okay, I can now say that v is equal to v2 because cos 60 is half. So 2v is equal to v2. So v2 is equal to 2v. Now we can now undo our system easily. Now we have the situation at hand that this v is equal to v1. 2v is equal to v2 is equal to v3. Now energy, kinetic energy plus the energy infused is equal to the energy in this three. Let's look at it now. So E, that is the kinetic energy. W is the energy infused. And then we have E1, E2, E3, the kinetic energy of the parts. So you can easily say that E plus W is equal to E1 plus E2 plus E3. And we are trying to get W now. So what is E? We know E to be half mv squared plus W is equal to, what is E1? Half m over 3 v squared. What is E2? Plus half m over 3 times 2v squared plus half m over 3 times 2v squared. Please don't forget, E, we have a figure for E, which is half mv squared. Now, let us half mv squared. Now, let us multiply through by 6. So, we are going to have 3mv squared is equal to plus 3w, 3mv squared plus 6w is equal to mv squared plus n into 2v squared plus, okay, let me add these two together. It will be 2mv n 2v squared. Now, this one now will give me, which will be n v squared plus 2 times n times 4v squared. So I'm going to have 3m v squared plus 6w is equal to, this is 8, 9m v squared. So let me subtract 3mv squared from both sides. So I have 6w is equal to 6mv squared. So w is equal to mv squared. Now note E equals half mv squared. Therefore, w will be equal to 2 times half mv squared, which is equal to 2e. So the work introduced is 2 of e. So w is equal to times half mv squared. Hence, work input is equal to 2 times E, while E is equal to half m